Good morning, students, and we have yet another snowy day. And thank you for joining us. I'm glad you're here. We're going to continue with systems of equations and solving them using elimination where the variables have no common coefficients. But before we do that, we'll start with our do now, and we have a prompt about supporting your dreams. You might have fun with that. Again, our objective is to solve systems of equations using elimination, but this time what's different is the variables will have no common coefficients. So we're making our job a little bit harder. So our essential question, of course, is how can I use elimination to solve a system of equations where there are no common coefficients? Okay, coefficient meaning 6x. 6 is the coefficient. Negative 3y. Negative 3 is the coefficient. So our assignment will be to do the do now in our class notebook. We have 5 problems today along with this video, but they're tricky. When you are finished, you will be excused from class. We will answer the exit ticket in class notebook and upload your completed assignment in Teams today. So our exit ticket will be, what new step must I perform when solving a system of equations that has no common coefficients if I determine that I need to use the elimination method? So for homework, we're doing homework 5-4, only the first 6 problems. So to get full credit, you want those A pluses in algebra. Our camera is on, at least at the beginning when we have our discussion. Respond when your name is called at the beginning, middle, of end of the period. Remember, on Whiteboard Wednesdays, our cameras are on. Ask for help when needed, and be your best learner today. So if you have questions, please email them to me. So just a reminder, tomorrow, Wednesday, is a full day of classes. Map testing begins the 4th and the 5th. We'll have the test for the first 2 hours, then 7 short periods for the remainder of the day. So please look out for those calendar invites. We have to change those and send them out to you. So here's our do now. It's a great one. Never be limited by other people's limited imaginations. Let me tell you a little about Mae Jemison. She was an African-American American engineer, physician. She was also a former NASA astronaut. She became the first Black woman to travel into space when she served as a mission specialist aboard the Space Shuttle Endeavour. So she says this is a highly accomplished woman, and she said, never be limited by other people's limited imaginations. She certainly must have had or imagined an awful lot for herself when she was younger. And sometimes people close to you, they think that they don't want to set you up for failure, so they think if they help you lower your expectations, they're helping you. But maybe you shouldn't have your expectations lowered, and maybe you should keep your dreams alive. Like they say, for when dreams die, it's like a broken winged bird that cannot fly. So the question today is, how will you convince the people close to you to support those unlimited dreams that you have? And I want you to think about how you can get the support of others and answer that right here. So we will come back to our exit ticket, but let's go straight to our whiteboard. And I want to just do a quick review of what we've done so far. So far, we've had problems that look like this. I'm going to put 5x equals, how about 5x minus y? I will change it up a little bit. 5x minus y equals 6. And then we'd have 5x plus 2y equals 3. Now, we know that we could just subtract the second equation from the first. So therefore, we've eliminated, that's why it's the elimination method, we've eliminated the x's, and negative y minus 2y. Remember, we're subtracting. Minus this 2y is negative 3y. and 6 minus 3 is 3, and we divide both sides by -3, and y equals -1. Then we would take that 1 and we would substitute it right into y right there. So we would have 5, and we'll solve for x. So 5x minus 1 equals 6. Well, my 5x minus -1 equals 6. Okay, so remember, subtracting a negative is like multiplying, in this case, a negative times a negative. 5x plus 1 equals 6. Now we subtract 1 from both sides, and we have 5x equals 5, and divide both sides by 5, and x equals 1. And the solution to this equation is 1, -1. Okay, going to change it up a little. We've got a new type of equation to show you. So let's look at, see, how about let's change our color first. And we'll work with x minus 2y equals 12, and 5x plus 3y equals -44. So I don't have any common coefficients. I've got 1x in the first equation, 2 and -2y. In the second equation, I have 5x, and I've got a positive 3y. So this is where we go to our new trick. We're going to multiply one or more of the equations so that we create matching opposite coefficients. So what I can do is let's get back to our page here. I can multiply this first equation by 5. And when I do that, 5 times x is 5x. It's really just distributing, right? Distributing is multiplying. 5 times -2 is -10y, and 5 times 12 is 60. Now, I just bring the second equation over. 5x plus 3y equals -44. Now, all I need to do is, now I'm back at the kind of problems we had yesterday. Just subtract the second equation. So 5x minus 5x, the x's are now eliminated. -10 minus 3y is -13y. Now, be careful. When you subtract a negative, it's really adding a positive. So it becomes 60 plus 44, which is 104. And then we will divide both sides by -13 to isolate y, and y equals -8. Now let's take the -8, and I'm going to go ahead and put the -8 in this first equation, the original equation. So when I rewrite that original equation, I have to solve for x. X minus 2 times -8 equals 12. Okay, -2 times -8 is positive 16. Subtract 16 from each side, and x equals -4. And the solution to this system of equations is -4, -8. So this extra step, we multiplied one or more, sometimes you have to do it to both equations, by some number so that you can get matching opposite coefficients. So let's start today's problems. Okay, so if there are no common coefficients, we need to multiply one or both equations by some number to create matching opposite. They need to be matching and opposite so that they can be eliminated coefficients. So let's get started. So we have x plus 3y equals 6, 2x minus 7y equals -1. I can take the first equation and multiply it by 2, so that I then have 2x plus 6y equals 12. Remember, multiply every term in the equation by that number. And then the second equation, 2x minus 7y equals -1, I can just take that equation and subtract it. And that eliminates the x's. Now remember, subtracting a negative is like adding a positive. So 6x minus -7y is adding 7 to give us 13y equals, same with this, it would be 12 plus 1, 13. And then when we divide both sides by 13, y equals 1. So now I'm going to take that 1 and I'm going to substitute it right in this first equation for y and solve for x. X plus 3 times 1 equals 6. X plus 3 equals 6. Subtract 3 from each side. And x equals 3. And the solution to this equation is 3, 1. And I've graphed these on Desmos. And there it is, the red line is x plus 3y equals 6. And the blue line is 2x minus 7y equals -1. And you can see the solution to that system of equations right there. So let's go on to number 2. I have 9x plus 3y equals 12, and 2x plus y equals 5. So if I take this equation, the second equation, and I multiply it by 3, I can eliminate the y's. That's going to be my goal. So let's rewrite these equations. So the first one, no changes will be made. 9x plus 3y equals 12. And the second one, 3 times 2 is 6x. 3 times 1 is 3y. And 5 times 3 is 15. Okay, so I need to subtract this. So 9x minus 6x is 3x. 3y minus 3y cancel. 12 minus 15 is -3. And then I'll divide both sides by 3, and x equals -1. And I'll take the -1 and I will put it, I'm going to use this second equation. It doesn't matter which one you use, but I always say smaller numbers are better numbers. Let's make it easy. So we have solved for x, so now we're going to solve for y. So 2 times -1 plus y equals 5. -2 plus y equals 5. Add 2 to both sides, and y equals 7. And the solution to this equation is -1, 7. And let's look at the graph. There's our 9x plus 3y equals 12, and 2x plus y equals 5. And I'll pull the graph down so you can see it a little better. And the solution to that equation is negative 1/7, exactly as we found it to be. Okay, problem number 3. We have 3x minus y equals 14 and 5x plus 4y equals 12. So I think what I'd like to do is eliminate the y's. So I will multiply the first equation by 4. And let's rewrite those equations. 4 times 3 is 12x. 4 times negative 1 is negative 4y. And 14 times 4 is 56. So let's not forget we have to multiply all terms in the equation. The second equation, we will just rewrite that. 5x plus 4y equals 12. Now, we don't have to subtract. We can just add them together, which is basically just combining them. 12 plus 5 is 17. The y's are eliminated. And put my x. 17x equals 56 plus 12, which is 68. Divide both sides by 17. And x equals 4. Now I will insert 4. I'll use the first original equation, and I'll insert 4 for x. So 3 times 4 minus y equals 14. 3 times 4 is 12 minus y equals 14. I will subtract 12 from each side, and I have negative y, don't forget your negative, equals equals 2. And then I'll divide by negative 1. And y equals negative 2. And my ordered pair is 4, negative 2. And let's take a look at the graph. So 2x plus, 3x minus y equals 14. And 5x plus 4y equals 12. Let's pull it up. And as you can see, the solution to the equation is 4, negative 2. Let's move on to problem number 4. X plus y equals negative 3, and 5x minus 2y equals negative 50. So I think I'm going to multiply the first equation by 2 and leave the second equation as is, and that will give me 2x plus 2y equals negative 6. And then I'll just simply write the second equation under it, lining it up. And I don't need to subtract, I just need to combine what's there by adding. So 2 plus 5 is 7x, and positive 2y, negative 2y, that's my elimination. And negative 6 plus negative 50 is negative 56. And I'll divide both sides of the equation by 7, and x, let me write that a little more neatly. X equals negative 8. I will substitute negative 8 in that first equation for x and solve for y. Negative 8 plus y equals negative 3. I'll add 8 to both sides, and y equals 5. And our ordered pair for this system, our solution is negative 8, 5. And let's look at the graph. So we had x plus y equals 3. That's the blue line. And 5x minus 2y equals 50. And our solution indeed is negative 8, 5, negative 8 on the x-axis, up 5, positive on the y-axis. And let's look at our final problem for today. Before we do our exit ticket, I've got 3x minus 3y equals negative 3. 2x minus y equals negative 5. Well, if I multiply this second equation by 3, and then I subtract, that's going to get me to where I need to be to eliminate those y's. So let's rewrite the first equation. Stays the same. 3x minus 3y equals negative 3. Now, 2x times 3 is 6x. Negative 1 times 3 is negative 3, and that's our y value. Negative 5 times 3 is negative 15. Now, this is where one of those places where you need to be very careful. We're going to subtract in order to cancel out the 3y, the negative 3y. So 3x minus 6x is negative 3x. Now 3y minus a negative 3y is the same as negative 3y plus 3y, and the y's will cancel. And then negative 3 minus a negative 15 is like plus 15, and negative 3 plus 15 is 12. Divide both sides by negative 3, and x equals negative 4. And let's put that negative 4. I'm going to use the second equation. It looks a little simpler. So I will substitute the x with a negative 4. 2 times negative 4 minus y equals negative 5. So 2 times negative 4 is negative 8, minus y equals negative 5. I will add 8 to both sides of this equation, and negative y equals 3. Then I will divide both sides of the equation by negative 1, so I can get rid of the negative sign in front of the y, and y equals negative 3. And our ordered pair is negative 4, negative 3. And once more, let's look at the graph. And there's 3x minus 3y equals negative 3, and 2x minus y equals negative 5. And there's our solution right there, negative 4, negative 3. So let's go back to our exit ticket. What new step must I perform when solving a system of linear equations that has no common coefficients? That's the key, no common coefficients, if I want to use the elimination method. So what you need to do is multiply one or both equations by some number. And you have to figure out what that will be, what will make sense given the problem. By some number to create matching opposite coefficients. So what do I need to do? I need to multiply one or both. Tomorrow we'll have some where we do both. Multiply one or both equations by some number to create matching opposite coefficients. So that's it for today. Make sure you've done your do now, some thoughtful response to that. Work hard. You have about 6 problems for homework. You'll see that right here in our informational box that's there every day. Homework 5.4, problems 1 to 6. As you get that extra practice, it will feel good and you'll be great.